and Casey? They don't care. They don't care. All right. We are today making a brochure for chapter 3. Listen. Brochure for chapter 3. Everybody has a blank sheet of paper in front of them, and Casey and Sarah, tomorrow when you are here, hopefully you're back by then, I have given blank sheets of paper to Rachel because I am going to be gone tomorrow. So Rachel is holding your blank sheets of paper unless you just want to, write this on a sheet of paper at home, whatever. This sheet of paper you can use on your test, and we're going to write out some important information on it, okay? So this is a brochure. This is like I've told them to put a fold right here in the paper and a fold right here in the paper. So they're tri-folding their paper like a brochure, and they have this going on here, okay? These are just lines. Don't fold them here, okay? Those are just lines drawn in your paper, all right? Okay, so things that we're going to write down. I'm going to zoom in on each box so you don't have to have these written down all to start with. This is vertex form, okay? So here we go. We're going to solve this, and we're going to find each one of these things, and we're going to graph it. This is what vertex form looks like. They call this transformation form. I call this vertex form. On the test, I will call it vertex form. It looks like that. And here is an example, and we're going to find each one of these things for that example, okay? Vertex form, vertex form. Okay? All right, ready? You got this all written down? Good to go? No. Okay, finding the vertex. When it is in vertex form, this is pretty easy to do. When it is in vertex form, okay? You look at these two numbers, and that tells you where your vertex is located. Emma Carr.
Yeah.
You need to...
I did.
But we're starting. Let's go.
But I did.
Okay, great. The vertex. When it's in vertex form, it makes it really easy to identify the vertex. What is it? Negative 3.
What? 4. Negative 4.
Negative 4. The only one that changes sign is this guy right here. Is the one that's in parentheses. So negative 3, negative 4, that's your vertex, yeah?
Is it always going to change?
What?
If it's positive, is it always going to be negative?
Yeah, yes, it's always, whenever, the one that's inside parentheses will always switch sign. Yes, correct. Okay? Vertex, pretty easy. All done. Okay? Next, x-intercepts. Another name for x-intercepts are
Roots.
zeros
Rounds.
or roots or solutions. I'm going to put zeros and roots into x-intercepts. That's what he means. Okay, we're going to find the roots of this equation. How do you find the roots?
You dig
0 in
you get about
for y. You plug 0 in for y. I made this come out really nicely, and I didn't mean to. You plug 0 in for y. So 0 equals, excuse me, negative 2. No, it doesn't come out nicely. Sorry, guys.
Positive 2. Oh, JK.
I'm just rewriting the whole thing with 0 plugged in for y. There he is. Okay? And then we add the 4 over. Jason's ready to go. Okay. 4 equals negative 2 times x plus 3 squared.
Divide by 2. Negative 2.
Divide by negative 2. Okay. X plus 3 squared is negative 2. Heavens. Oh, yuck. Now we take the square root of it. What's the square root of negative 2?
Good question. Imaginary.
Plus and minus the square root of 2. I equals x plus 3. Okay. The square root of negative 2, that negative pops out as an I. Why do we have to have the square root in there, or the plus or minus in there? We put the square root in there. Okay, then we subtract the 3 over, and I write my answer as like x equals negative 3 plus or minus the square root of 2i. Okay, there is my zeros. Those came out really gross on the test. I don't think I make them come out that ugly. But anyway, it's not too bad. Okay, so what does that mean for zeros?
That's where they hit.
Where do they hit?
At negative 3 plus.
That means my zeros are negative 3 plus and minus the square root of 2i, but it's imaginary. So what does that mean?
They're not there.
I have no zeros.
Not real.
If it's imaginary,
We're going to talk about what that means. If it's imaginary, that means it's crossing the x-axis, so the x-intercepts are imaginary. It's crossing in an imaginary place, which means it's not crossing, right? So we'll talk about what that means here in a second. Okay? It's not crossing. The y-intercepts. How do you find y-intercepts?
Look, 0 in for x.
0 in for x. 0 in for x. Okay, so y, let me go in a different color. Y is equal to, was it negative 2? And then we plug 0 in, 0 plus 3 squared minus 4. Did I do that right? Yep. Okay, and then we just plug stuff in. Oh, heavens, we're going to have a way big negative number. 0 plus 3 is 3. 3 squared is 9. And 9 times negative 2 is negative 18 minus 4. The y-intercept is?
Is this y-intercept?
Negative 22.
Negative 22 is the y-intercept. Yuck. Okay, so let's graph him. I'm going to do a graph down here below because y-intercept doesn't take very much space. So if you have a place to graph him down below, here he is. The y-intercept is negative 22, but let's graph the vertex first. Vertex is negative 3, negative 4. Negative 1, 2, 3, negative 1, 2, 3, 4, and he's right here, okay? Negative 22 is where he's crossing right here, so he looks something like this.
It's going down, so
He's going down, so this shows me that I have no zeros, right? Because we got imaginary numbers for our zeros, correct? Okay, no zeros. None at all, none at all. There he is, that's what he looks like, okay?
Can you scroll up? I didn't get it.
Moving on.
None of us.
Okay. All right, happy with that?
I'm having chili.
Okay.
Guess what I'm
Yeah, I
having?
thought we did that.
Chili
before, by the way.
tonight. Class.
You said that you didn't.
What?
I
It's
ate
snowing.
lunch.
Okay, moving on. Let's go to this one. This one is in standard form. We're going to still find the vertex. If you need to label him here as
You
well.
want to know?
I didn't get any of that. What is this?
You're not writing fast enough. Nope, x-intercepts.
Sarah makes all the good things. And
I made it.
first
We're having cake.
show up at my house. I'm having corn.
If you need to write those down again, you sure can. If you don't want to, that's fine.
Dum dum bubble.
Okay, we can stop now and you guys can fill this in by yourself. Okay, then be quiet and listen.
Shut up.
Okay, the vertex.
Yeah, what Jason said.
The vertex, when it is in standard form, is kind of gross. It's not quite as straightforward as vertex form is over here. How do you find the vertex when it's in standard form?
I don't remember.
4, negative 5.
No,
Plug it in on your calculator.
no, you do not. I'm gonna make him smaller. There's a formula for it. It's a little tiny little piece.
It's
Negative
over
b
2a.
plus minus
Quadratic
square root.
thing.
Negative b over 2a.
Negative b.
Yeah, it's kind of part of that. Negative b over 2a. Now, how do you find the y coordinate though?
Plug her in.
You plug in, right? So negative b over 2a and then plug in to find the second piece. Okay, let's do ABC over here.
You're moving too fast, Amateur.
You're not moving fast enough.
Negative
Let's go.
4.
What is, hold on, what is A in this problem? 1, what's B?
4.
4C? Negative 5. We don't care about C, but we're writing it anyway. All right, negative B over 2A. Negative 4 over
2.
2 times 1, which is 2. So negative 4 over 2 is
Negative 2.
negative 2 comma something. We have to figure out what that is,
Then you plug that in
right?
for
We
x.
plug them in. Negative 2 squared
4.
plus 4 times negative 2 minus 5. Okay, so this guy comes out to be
Plus 5.
positive 4.
What?
Whoa.
Negative or positive.
Minus.
Minus 8 minus 5. What's 4 minus 8 minus 5?
Negative
Good
9.
question.
Negative 9. Negative 2, negative 9. That is
You were
my
off.
vertex.
What? You
Okay.
were one off.
So it is not quite as straightforward as what it is when we're in vertex form. So there's that. Okay,
We
good.
do the
No.
same.
Okay. All right, keep it going.
So the x and y is the same.
Yep.
Oh no.
All right, moving on. Ready? Maybe? X-intercepts. How do you find the x-intercepts?
0 in for y.
Still plug 0 in for y.
My coffee socks.
You still plug 0 in for y. 0 equals x squared plus 4x minus 5. Okay, now what? This is slightly unpleasant. Nope, we don't want a plus 5. Nope.
Quadratic
What is,
formula.
nope, what is this
Break it
thing?
down.
What is that thing?
Like a simple triangle.
Yeah, we can break it down, right?
Break it down.
Let's break it down. Okay. What can you multiply to get negative 5, but when you add them give you 4?
Negative 1.
Negative
4 and negative 1.
X minus 1, x plus 5?
X equals 1, X equals...
Is that correct? Is that correct, Emma?
No. Which one?
Negative 1 times 5 is negative 5.
I thought we
Negative
were
1 plus
multiplying
5
to
is
get
4. No,
4.
you always multiply to get the last number,
Oh, poop.
right? Because when you FOIL, that last number is your L of your FOIL, right? The last two things multiplied together give you the last number, right?
I suppose.
Okay, so x equals
1
1 and x equals negative 5. You betcha, there they are. Okay, those are the two zeros. I do have two places where he's crossing it. Those two places, yeah? Simple trinomial. Simple
Next.
trinomial. Next, find the y-intercept. So we
Y equals -5.
Plug 0. I'm going to just do 0 in for x.
Just put 0 for x.
0 in for x. So y equals 0 squared. I forgot what my numbers were. Plus 4 times 0 minus 5. Okay. This one's really nice
Y equals -5.
because it's just y equals -5. That is my y-intercept. Let's graph him to see what he looks like. We have -5. 1, 2, 3, 4, 5. There he is right there. My zeros are 1 right here and -5. 1, 2, 3, 4, 5 right there. And the vertex is at -2, -9, like all the way down here, and that's what he looks like right there.
-2.
Something of that nature, right? That's what he looks like. Good? Okay.
So,
All right, now I likely will not ask you to do all 3 of these things for one problem. I might just say, find the vertex of this guy, okay? But here's the deal. I won't tell you what form you're in, right? You have to identify that. Pretty easy to identify. Is it in vertex form? Is it standard form? Or is it factored form? But then you can find the vertex from there by using this cheat sheet, yeah?
The factored form
Okay.
is pretty easy to find though.
Right, exactly. We're going to go through that here in a second, Amakar. Okay, hold on.
Wait,
So,
let me
here we
write
go.
this down. Wait, pause. Y.
Okay, so here is this one. This is my example. 3 times x plus 2, and then x minus 4. There he is. Okay?
Wait, I'm writing down. Y.
All right, we're going to do this out of order.
Why would you do that?
We're going to do this one out of order. We're going to do the x-intercepts first.
They're right there. Just
Okay.
kidding.
Okay, so this guy is still the vertex. So we still got vertex here. If you need to label these, go for it. Vertex, the x-intercepts, and the y-intercepts. Okay, there they are. All right, we're going to do that. Let's find the x-intercepts first because it's going to make more sense when we're finding the vertex. Okay, still for x-intercepts, we have 0 in for y. 0 in for y. Plugging that in. 0 equals 3 times x plus 2 and x minus 4. There he is. Okay?
Wait, no.
0 in for y. There he is.
Good.
Okay? All right, what do we do first?
Divide the 3.
Divide the 3 over. We can totally do that. Divide by 3, divide by 3. There he is. What's 0 divided by 3?
0.
Still 0. So that 3 does nothing to change the zeros. Okay, then I set that. No, you don't want to foil because then you'll get back to you'll get him in standard form.
It's literally just x is
X equals
minus
-2
2 and positive 4.
X equals -2, x equals positive 4. Okay? Good?
Yeah.
Yes?
So good.
Great. X equals -2, x equals 4. Okay, now I'm going to go down here to the bottom and I'm going to graph that. Okay, just really quick, I'm going to graph him because we're going to have room at the bottom here. And we have -2 and positive 4. Okay? Check this out.
Right?
-2, put a dot. Positive 4, put a dot. There he is. Okay? -2, put a dot. Positive 4, put a dot. Right? Those are my 2 zeros. Okay? This parabola. Okay? Check this out. That's where your vertex is going to be, is right in the middle, right? Here is -2. Here is positive 4, right? Your vertex is going to be exactly in the middle of those, somewhere along that line, right? That's where the axis of symmetry is. Yes, correct. Okay, so we know from the vertex that the x coordinate, this guy has to be the average of -2 and 4. It's exactly in the middle. What's the average or exactly the middle of -2 and 4? 1, right? So we know that he is that, right? And then we just plug the 1 in to solve the other guy. Okay, so let's go back up to the vertex. And I'm going to tell you that the formula for finding the vertex, here's the formula for finding the vertex. You take the average of the zeros. Does that make sense? You take the average of the zeros. Okay? So my zeros.
What does that even mean?
What does that even mean? We're going to go through that. The average of the zeros. You're averaging the zeros together. So what are my 2 zeros?
2 and -4.
And your mom and your dad.
-2 and positive 4. And we're dividing that by 2 because that's how you find the average, right? Or exactly in the middle. If it helps you to draw it out, do it. Okay? -2 plus 4 is positive 2. Positive 2 divided by 2 is 1. There is my x coordinate of my vertex. And now what?
You plug it in. 1 in.
You plug it in. After you find that number, you plug it in. So plug in 1. So we have 3 times 1 plus 2 times 1 minus 4.
And the answer
Okay.
is.
And the answer is, I don't know, we're going to find out. 1 times 2 is 3. 1 minus 4 is negative 3. 3 times 3 is 9. 9 times negative 3 is, holy cow.
Negative 27.
Sorry, that's really, really disgusting. 1, negative 27. I don't know. I don't know.
Why would
1,
you
negative
do that
27.
to us?
I don't know.
That was rude.
I don't know.
Okay, 1, negative 27. Do you see how that works?
Yeah.
Okay,
Oh, I see it all right.
1, negative 27 is like all the way down here.
What is it?
Whatever. So that's what he looks like.
What was that?
Okay, this
What
is 1, negative 27. Okay.
Uh,
All right, when you look back at this, are you going to remember or know what averaging those two values like represents?
Yes.
Like, what does that mean, right? Okay, now,
hey, but
let's
you know,
suppose.
wait.
Hold
You
on, just wait a second, Emma Carr.
No,
Just wait a second, Emma Carr.
You wait.
Just wait a second, Emma Carr. No. Hold on.
I have something.
Here's the deal. Let's say your brain turns to mush.
That happens a lot.
Let's say your brain turns to mush on this test. Are you ready?
Yeah,
Okay.
and just start.
No, hold
playing
on. Just wait a second. Let's say your brain turns to mush on this test. Okay? Kira can relate because she's smiling and laughing right now. All right. Let's say your brain turns to mush right now. Okay, so here's the deal. This is in factored form, right? Okay? And let's say I have no idea how to find the vertex and all that good junk, right? Could I switch factored form and FOIL that out and make him into standard form and then just follow this process?
Yeah, we did that for a whole lesson.
We did that for a whole lesson, right? So that is totally an option. Same thing with this one over here. If you get stuck, FOIL this guy out. Make him in this form, and then you can do all that stuff to it, right? If your brain turns to mush, you can always do it a different way, right? You can always.
Okay, can I say my thing now?
Okay, hold on. What?
Okay, guess what?
What?
So we already know that the y is gonna be in between negative 27 and that.
Correct.
It's negative
Correct.
24.
Yes.
Yeah. that was
It's
pretty-
it's
Yeah.
negative
So
24.
don't do that.
Okay.
Yeah.
So to find the y-intercept, we got to do that one yet. 0 in for the x. Okay, so we've got y equals. It was at 3, and we've got 0. I don't remember what it was. 0 plus 2
X minus
and
4.
0 minus 4. There he is. Okay, we're plugging 0 in for x. Okay, 0 plus 2 is 2. 0 minus 4 is negative 4.
24.
3 times 2 is 6 times negative 4 is negative 24, and that is consistent with what Emma said. She says it's got to be some number between negative 27 and 0 right here. It's got to cross somewhere along this line, and it is crossing at negative 24. There he is, right there.
Bam! And
Bam. She got it. Okay,
Hold her up.
good?
Put her away.
Happy with that? Nope, we're not done yet. We got to put something on the backside.
Or answers to the test.
Correct. We want to write as much on this thing as possible.
Go back to the y-intercept.
Yep, there you go. Okay. Oh, vertex form? This one?
Yes.
Okay, flip your paper over to the back side. We're going to get ready to go on that one.
That was uncalled for.
There are 3 things, and this is still tri-folded. We still have 3 things that we're checking for. Okay.
Yeah, you can go.
Still have 3 things that we're checking for. All right, here we go. So I'm going to continue my lines on down.
Boom. We have a whole back page.
You have a whole back page. Here we go.
I don't know if I believe.
I got it.
No.
Well, it's not going to take a full back page. Here's your pieces.
Awkward conversation into a part of.
I think you
Let's do this.
You think we should pray for him? We should pray for
Here, I'll take it.
Have that back.
I say that all the time.
Yeah, but can I have some food? Do you have food?
Hey, can I have that back, Gracie?
No.
All right, write this down.
Can I have that back?
This is on the front.
This is on the back side. So your tri-folded section, this is still on the back side.
Mom yesterday. She kept bumping into me at church, so I punched her.
Literally punched her in the face. Like, that's
My mom punched me in the
All right.
face. I punched her in the shoulder. She
Hey,
punched my
guys.
face, and she goes, Gracie should probably
Write
go to
this
bed."
down.
She just punched me.
Write this down.
It's like, mother.
You punched your mom in the face
In
in
the
church.
shoulder. It's the shoulder.
It's the shoulder.
In church.
No, we were in the other room. Because she kept bumping into me, and I almost ran into an old dude.
So you just turned around and socked her?
Yes.
About what?
And she goes,
The
I'm
girl?
gonna have a bruise. I bruise easily. I'm like,
Just
Oh.
I do too.
Why did you punch her?
Because she kept
Yeah, are you gonna make out with her or not?
And Jenny allowed you to punch her?
No.
Literally die.
She didn't allow it. I
She didn't
just did it.
retaliate?
No, you just go,
Great.
ow!
I know someone who can make
I
that
can
with
imagine
stay
that
friends.
right now.
Bleh.
That was crazy the whole movie
That
yesterday.
was you too. No, I was just trying to eat my pickle chips, and then all of a sudden somebody gets stabbed in the throat.
Through a confetti.
Are you
box,
writing
she
this
goes,
down?
You eat pickle chips, but you don't like pickles.
I like the taste of pickle, just not the texture.
What?
What?
So do you like cucumbers?
Yes? That makes
What?
absolutely no,
No.
sense. Of what's
Exact opposite. Pickles are so good. Cucumbers are
Okay, are you writing this down, folks?
All of them are good.
Yeah.
He's on.
Pickles are amazing.
Are you writing this
I
down?
already wrote it
Grandma,
down.
did you eat all that candy?
I know.
No,
Bring me
I
some.
felt like my teeth were gonna fall out, and
You
I
guys
thought I
need
was
some
gonna
candy
barf
because
it
my
out.
brother's got a whole
Yes.
bunch. They had to.
I already
Okay,
went through
you're
my
not writing this
backpack.
down. Let's get going. Come on.
One.
I've been writing this whole time, so you're not done yet.
We're just fast.
Let's see the backside,
Uh-huh.
okay?
What's the backside?
Oh,
Cray, you cannot afford not to do well, sir.
Neither can I.
Hey,
So
my
it's
grade
okay,
isn't even
Gray.
that bad in here right now.
You just started the new,
So,
like the new,
You can buy your grades
is
if
that?
you have really
Quarter.
a lot of money.
how much? Comager, how much money would it
Too
take
much.
for you?
You have dropouts
Like,
at 16.
Would you,
Too
if
much.
someone came and offered you $4 million,
No, you have to
Sure.
be
I'll be
Would you
18
do it?
this summer.
No,
You
you
wanna
can
do
be.
it?
Can you be?
No, they changed it.
16
They
million.
changed it.
All right, moving on.
Year.
Okay.
That is such a lie.
We're ready. Here we go. Y-axis symmetry. Let's start with this function. That's my example.
I'm a senior.
We got to figure out what we plug in. When you're doing y-axis symmetry, what do you plug in for x and y?
Do
Negative X.
The x becomes negative. The y stays the same, but the x becomes negative, right? Do you remember that? Okay. So we are going to plug all of the x's are going to change to negative x's. The y is just going to chill, but all of these x's are going to become negative x's.
are they?
They are.
They are.
Just like that. That's what we're going to do.
They are.
Wait, my pencil's not working. And then if it's the same.
Okay. Then if it's the same as what it was originally, then we are good to go.
No way.
Okay.
No, it is.
All right. So this y just chills. What happens if we take negative x to the fourth power? It turns positive. It's positive x to the fourth. Plus, what happens when we take negative x squared?
This is positive.
It becomes positive. Okay. Now, is this the same as what we started with?
Yep.
Hey, why are you?
So-
Hey.
So, what does this mean?
And that has y-axis symmetry.
This has y-axis symmetry
How? Oh.
Because it's the same as.
because it's the same as what it was to start
why
with.
Did you?
It switches back to the original.
No. Why did you?
The
switch it back
trick
to the
is-
original?
Because if you take negative x to the fourth power,
Stays the same.
Emilcar, if you take negative x to the fourth power, negative x times negative x times negative x times, then it's positive x to the fourth power,
But
right?
no, it's not.
Yes.
It's not. If you take it to the fourth power, then it's not still to the fourth power.
Yes, it is.
It just,
Girl,
it's just saying
okay,
that if
look at this.
Oh no, it ain't.
Child, look at this. Negative x times negative x times negative x times negative x. Oop, negative x.
It's just x.
No. Okay,
Oh my.
two negatives make a positive, so those both become positive. But how many x's
And
do
then
that?
it's squared.
No, it's x to the fourth power.
What?
Girl, there's still four x's.
Yeah,
Oh
but
my heavens, child.
You can't
There's still
just-
four x's.
But you can't just.
Yes.
You
Yes.
can't just skip it.
Yes, you can. No, child. Okay, moving on. This has y-axis symmetry. You can argue with me later. All right.
Okay.
This
but
has
no, I
y-axis
just don't
symmetry.
understand it.
Okay, moving on to the next one. If you're trying to do x-axis symmetry,
Make the y negative.
you make the y negative. Okay? All right, so here we go. All the y's become negative, and there's only one y. The x just chills. He just stays the same. What happens if we take negative y times negative y?
It's y squared.
It's positive y squared.
So it's the same.
So he flips back. Is he the same as what he was?
Yes.
Same. Question mark.
What?
Yes.
So the negatives.
This
So it best as well just not
has
even negative.
x-axis symmetry.
So basically, it might as well just not even have a negative because it's not.
Correct.
negative.
Correct. Right. Right. Okay. This has x-axis symmetry. Moving on. Yes.
Moving on.
Okay.
Origin symmetry.
I already did that one. May I go?
Origin symmetry. What do you plug in?
Negative for both.
Negative for both x and y. Okay. So I'm gonna plug in negative x, negative y, negative x, negative y. That's what he looks like. Okay.
So
Divide by negative.
Hold on. Just wait a second. Wait a second. Wait a second. We don't have to divide by negative, child.
They all are just turned positive.
Okay, whatever.
Okay.
I divided
What
by
is
x.
negative x times negative y? Just xy, right? The negatives cancel out. What is negative x squared?
X squared.
Positive x squared. What's negative y squared?
Y squared.
Is this the same as what it was originally?
Yes.
Yeah.
This
Okay,
has
so-
origin
This has origin symmetry.
symmetry.
Can I go to the restroom?
Hold on,
Done.
hold on, hold on, hold on.
Oh my goodness gracious.
Now, would you like to see one that doesn't come out, or do you guys understand that?
No, I got it.
You guys understand that it won't always come out? So if it doesn't switch back to the original, then it's not. Okay, now, one more thing I will add. It is an even function. It's considered to be an even function if what?
Y axis. What is this?
Oh yeah. Oh,
These
yeah,
are
yeah.
even functions.
That's a good thing to say.
Yep.
Why did you open it?
These are even functions.
And then
Odd is origin.
Odd
What?
is an origin
Get
symmetry.
it.
What's the middle one?
It's not a function.
Okay, it's not even a function. So listen to this.
I just ate one.
On the test, if I ask you, is this function an even function? What am I asking you to do?
Does it have y axis symmetry?
Ask does it have y-axis symmetry? If I say, is this an odd function? You're testing to see whether it has origin symmetry. Okay? Now, do not on the test just say yes or no. Right?
What?
Because even if you're correct and you don't show any work, I will count it wrong.
Wait.
So I will count it half wrong if you are wrong.
We can't just say yes if we show our work. Then
Right,
you lie.
right. So it is a yes or no question, but if you don't show your work and you just guess, I will count it wrong. Correct, 100%. Okay? All right, happy with that? That's the stuff that you need to know. All right, for the people in this video, everybody else be quiet. I've already said this, but listen to this again. For the people that are watching this video, tomorrow I will be gone. You guys have the review for chapter 3. You are going to do the review for chapter 3 and have it ready to go for tomorrow. Tomorrow I will leave you a video that goes through all of the problems on chapter 3. So you will have the answers to that review in the video. Okay? But I don't want you just to look at the video and get the answers, because I'm probably not even going to take the review for a grade, or I might take it as a check mark grade. We'll see. What I want you to do is know how to do the problems on the review, and we can check them tomorrow in the video so that you're ready to go for the test, which is Wednesday. Without a doubt, 100%. Wednesday is the test. Be ready for that. Okay? Be ready for that. All right? Everybody say bye, Casey and Sarah.
Bye.
Adios.